2, lesson 18, we're going to be talking about calculating with units of measure. This is going to involve a lot of unit conversion, which I don't sure how much of this you're familiar with yet, but we'll work out some questions here in a little bit. There's not a whole lot of notes in here. They actually, it says that this is dealing with units of measure. Really, probably the bigger section of this is actually dealing with significant digits. So we can use unit conversion factors to change one unit of measure to another. So if we're converting from feet to inches or even miles to meters, right, we'll use unit conversion. So dimensional analysis involves choosing the appropriate conversion factor to produce the appropriate unit. And we'll talk about the correct process for converting into different units. Sometimes you may need to use more than one conversion factor, right? If we're trying to convert from miles to meters or miles to kilometers. Miles to kilometers actually does have kind of a one-to-one across, but if we were doing miles to meters, we'd have to convert miles to feet, feet to inches, inches over to centimeters, centimeters back up to meters, because the crossover point for converting most of your distances from English to metric or metric to English actually crosses over between centimeters and inches. Okay, so knowing what your conversion factors are is important. Knowing, how many feet are in a yard, knowing how many inches are in a foot, knowing how many centimeters are in a meter, how many meters are in a kilometer, those types of things are conversion factors that you need to know. And this lesson doesn't necessarily go into all of those, but they are ones that you need to know. Some of the ones that are a little harder that we don't talk about a whole lot are like pints and quarts, things like that. Even weight, pounds to kilograms or ounces in terms of weight versus ounces in terms of fluid. But in any case, so the accuracy of a measure, accuracy and precision are two different things. People use accuracy and precision in comments. They don't mean the same thing. Accuracy of a measure refers to how closely it corresponds to the actual value being measured. So how accurate I am is how close to the correct answer I am. Okay? So if we're talking about, I'm trying to think of what term we've used. Percent error. Percent error is based upon accuracy. What percentage or how close was I to the real answer? Okay? But precision is different. The precision of a measurement refers to the number of significant digits it contains. So precision, if we were getting something down to, well, let's think about GPS for a second. GPS has changed over the years, right? The GPS in your car in terms of accuracy. I know a lot of you guys don't drive, but it's always been funny to me driving down the road and see the GPS be off by about, maybe sometimes 50 feet, where if you've ever been driving down the road with somebody who was using GPS, and the GPS had you driving out in some field next to the highway. Has that ever happened to you? It didn't actually have you on the road, it had you out. I've been out in a lake somewhere, driving through the middle of a lake. All right? That's because the precision of the GPS may only be, hey, the GPS can get you within 50 feet of your actual location. All right, but GPS has gotten better over the years to where they can get you within maybe 10 feet of where you actually are. Okay, for instance, whenever I'm out running on the track or out running on the highway, I can tell you that the GPS in an Apple Watch is not perfectly accurate. Okay, because I'll have headphones in, and I'll run the Nike Run app, and so it'll tell me when I've finished a mile and at what pace. The problem is that it doesn't tell me I finished a mile when I cross the finish line. It may have me run an extra 20 feet, or it may tell me that I'm done with a mile 20 feet before I cross the finish line. So you see the difference. That's not super precise all the time. Okay, in fact, the more laps you run around that track, the less precise it actually gets. The first mile is pretty accurate. Second is going to be less. Third is even further. In fact, I think I ran 4 miles out on the track a couple of weeks ago, and it said that I finished my 4th mile whenever I crossed the 200-meter mark of the backstretch. right? It was a whole 200 meters off from where I was supposed to actually finish at. So that's just kind of a for instance, okay? So our significant digits aren't super accurate. So the table that we're going to look at shows us how to find the number of significant digits in a measured value. So this is a chart you're going to want to refer back to or write down or do something with, because up to this point we really haven't asked you to answer questions in terms of significant digits. Remember, this is not scientific notation here. We're talking about significant digits. So we've got a rule. We actually have about four or five rules. First rule is non-zero digits are significant, always. So if it's not zero, you count it. Okay? So you count them up. So 325.6 has 4 significant digits. Zeros that show up between non-zero numbers are significant. So those zeros between 5 and 3 and between 3 and 9 are significant. So there's 6 significant digits there. Okay, does that make sense? Now, here's where we find out where zeros are not significant. If zeros show up before a non-zero number with no other, and they show up completely before, they're not counted as significant. So 0.00047 only has 2 significant digits. Okay? But zeros that show up after my non-zero numbers are significant. So the ones that show up at 0.000, those are insignificant or not significant, but the zeros that show up after the 18 are. So that has 4 significant digits. So those are the 4 rules that you want to know when identifying significant digits because of what comes next. Okay? So these rules are used to determine the number of significant digits that should be in our answer to a calculation with measurements. So, and I don't know why they split this up the way that they did, because it's the same rule for addition and subtraction as it is for multiplication and division, which means if I'm adding, subtracting, multiplying, or dividing numbers, I'm always going to have my answer match the number used in a problem that has the least number of significant digits. Okay? So if I'm taking 1 mile times, and it's just a whole number, times 0.33347, or something like that, I'm going to go with that whole number because that's the least number of significant digits. All right, so when adding or subtracting, the answer should have the same number of decimal places as the measurement with the fewest decimal places. When multiplying or dividing, the answer should have the same number of significant digits as the measurement with the fewest significant digits. So they say that twice, and hopefully I've written that down right. But that's that. So let's see, and I need to actually pull it up. Let's work out some problems here. Let's see, this is lesson 18? Great. I know it seems like something that I should know, but like when you teach 4 different math classes, you're like, I don't know what number we're on in which class. I do my best to keep up with it, but in the moment, probably not going to do a very good job. All right. So when Amy roller skates, she moves 110 yards per minute. What is her speed in miles per hour? Round your answer to the nearest hundredth. Okay, I think what I want to do with these questions, because they require some writing. That's some Algebra 3 work right there. Okay, let's see this. Okay. So what we're starting off with, she is at 110 yards per minute. 110 yards over 1 minute. Okay, we want to know her speed in miles per hour. So we actually need to do a couple of different conversions. We need to convert yards to miles, and we need to convert minutes to hours. Okay, and I know that you know how to do this because I taught this in like 7th grade, whenever I taught 7th grade math. I know that you guys know how to convert. I taught 7th and 8th grade math my first year teaching here. So back in 2014, I taught 7th and 8th. So I didn't teach you this, but I did teach this. All right, do we want to convert minutes to hours, or do we want to convert yards to miles first? Minutes to hours. Okay, so in order to convert minutes to hours, notice that minutes over here shows up in the denominator position. So I need to put minutes in my conversion, but where do I put it? Top, because I need it to cancel out, right? Which means hours are going to go down here. All right, now, the next rule, besides knowing where to put my units, is knowing that whenever I'm converting, that what I'm multiplying by should be equal to 1, right? So there are 60 minutes in 1 hour. All right, that's equivalent to 1. All right, because they're equivalent. All right, so the biggest unit involved in a conversion will always get the number 1. All right, so what's bigger, minutes or hours? Hours. So hours is going to get the number 1, okay, and we're going to have 60 minutes in 1 hour. All right, does that make sense? All right, so we could go ahead and figure that out, but we're actually going to go on and we're going to convert at the same time, we're going to convert 110 yards into miles. Okay, well, I don't know how many yards are in a mile, but I do know how many feet are in a mile. So can I convert yards to feet? Sure, but where do I put yards at? Yards, okay, yards on the bottom, feet on top. Which one gets the 1? Yards, so how many feet are in a yard? 3. Okay, there's 3 feet in a yard. Now can I convert feet to miles? All right, where do feet go? Bottom. Miles on top. Which one's bigger? Miles. Okay. Miles are bigger than feet. I don't know what kind of size feet you're wearing, size shoe you're wearing. All right. So there are how many feet in a mile? All right. So we got to have the right numbers. Now I should have everything that I need in order to convert her 110 yards per minute into miles per hour. So I'm going to multiply across the top. So 110 times 60 times 3. I don't need to multiply by 1 because that's not going to change anything. 19,800. Now I need to divide that by my number on the bottom. Notice that it's 1, 1, 1. Is that going to change anything? So all I need to do is divide by 5,280. So what do you get? So my answer is 3.75 miles per hour. Okay? Which is really, really slow. Okay? If she's only roller skating 3.75 miles per hour, I think I run at like 7 miles per hour or something like that, 7 or 8 miles per hour. So, I mean, she's not roller skating. She's roller skating basically half of what a very average person can run. Yeah, maybe. I don't know. All right, let's see. Some of these get a little bit more tricky. Your next question that shows up here, it says, working as a salesman, James visits 10 cities per week. All right, so 10 cities per 1 week, right? Okay. At this rate, about how many cities would he visit in 1 year? Okay. So we need to find out how many weeks are in a year, right? Okay. So what we're going to do is we're going to put weeks at the top, years at the bottom. Okay, which one's bigger? Year. So 1. All right. How many weeks are in a year? 52 weeks in a year. That's it. Well, I don't need to convert cities. All right. So this is per 1 year. Okay. So I'm just doing 10 times 52, right? So we should get 520 cities per 1 year. Okay. And so I'm going to say that James gets around. 520 cities in a year, that's more than a city. That's way more than a city a day. So, okay. All right, this next question involves significant digits. Okay, the question is, we want to calculate 371.609 plus 166.7. Okay, and the whole thing is in yards. Okay, how many significant digits does this first number have? This first number, 6. How many significant digits does the other one have? 4. Okay, how many significant digits should our answer have? You add up the significant digits? Guys, go back and look at your notes. Right? There's a whole, in fact, you can look at this on 125, rules of significant digits in measurement, tells you how many significant digits you should have when you add, subtract, multiply, or divide numbers. Okay, nowhere did I tell you to add up the significant digits. Then 4, yes, because you're going to pick the number that has the fewest number of significant digits. Now let's go ahead and add this. What's, make sure I got that, 371, 371.609 plus 166.7. Can anybody tell me, just give me the, 538.309. Okay. I wanted just the original number. So what is going to be our number with significant digits being 4? 538.3. Okay, that's where we stop. Okay. All right. Do you guys feel like you've got a decent handle on this now? Okay, we've done, I mean, I know that we've only done 3 questions, but do we get it? Yes? Okay. All right. I'm going to hit stop right there, and we'll get the recording sent out to you.